Welcome back to Tales of Chemistry. In this episode, let us learn how to write the formula of a compound from its name. Okay, so from the IUPAC name of a coordination compound, how can we write its formula? So the first example that we are going to take is pentaamine nitrito N cobalt 3 and ion, which means this is not a coordination compound. This is just a complex ion. And cobalt here, it's not cobaltate, but cobalt. So we can understand that this is a cationic complex. Now, pentaamine, amine is NH3, 5 times, NH3 5 times pentaamine. Nitrito N, nitrito N is NO2. If it is nitrito O, then, we need to write ONO. So this is nitrito N. The metal is cobalt. Put this in the square bracket. Now, charge on the complex can be calculated using the oxidation number of the metal which is given. So this is 3 plus, a minus 0, and this is minus 1. So the net charge here is 3 plus and minus 1 plus 2. So plus 2 has to be the charge on the complex ion. So answer, what I mean by answer is the name, the formula of the compound is CONH3 5 times NO2 2 plus. All right. Now, nitrito N is NO2. Nitrito O is ONO. The rest everything is clear, I guess. Now, moving on with the second example, triamine bromido nitro cobalt 2. Okay, now triamine is NH3 3 times. Bromido, Br. Instead of nitrito N, they have just written nitro here. So, NO2 itself is what they mean. Central metal is cobalt. Okay, now charge on the central metal is 2 plus, this is 0, this is minus 1, minus 1. So the net charge is 0 inside, therefore charge on the complex is also 0. So your formula here is CONH3 3 times Br and NO2. We are done with the second example. Moving on with the third example, tetraamine diaqua copper 2 sulfate, tetraamine diaqua copper 2 sulfate. Amine is NH3 4 times, diaqua H2O 2 times, copper Cu and SO4 sulfate. Now charge, this is 2 plus 0, 0 and minus 2. The charge is balanced. So your final presentation answer is to be presented CuNH3 4, H2O twice, SO4. So this is how we write the formula if the name is given. Moving on, Potassium dicyano. Next example, potassium dicyano or cyanido argentate. Argentate 1. Potassium, I'm just writing K. Argentate, so silver, Ag. Dicyano, Cn twice. Now, charge on the metal is plus 1 because the charge given is 1 in Roman numeral. Plus 1 minus 1 into 2 minus 2. So the charge within the complex is minus 1. The charge outside the complex need to be plus 1. And I have a potassium to show the plus 1 charge. Okay, so that is it about potassium dicyano argentate. So you need to present your answer without the charges K, Ag, Cn twice. Next example, let us take potassium tetracyanonickelate. Potassium tetracyanonickelate 0. Now, potassium, I'm writing K. Tetracyano, Cn 4 times. Nickel, Ni. Now, charge on the metal is 0. Cyanide is minus 1 and 4 such cyanides. Net result is minus 4. Now, charge within the complex is minus 4. Therefore, charge outside the complex also should be 4, plus 4. But 1 potassium can give you only a positive charge, plus 1, and you need plus 4. So what is the option? Right, K4, 4 potassium ions together makes the charge plus 4. The charge due to the complex ion is minus 4. Therefore, the net charge on the complex compound is 0. Next example, triamine, triaqua, chromium 3 chloride. Triamine, triaqua, chromium 3 chloride. So NH3 3 times, aqua H2O 3 times, chromium Cr bracket, charge on chromium is 0. This is 0. Charge on chromium is plus 3. NH3's charge is 0. Water, aqua, charge 0. Counter ion is Cl. Now, what's the net charge inside the square bracket, inside that coordination sphere? Charge is plus 3, which means charge outside has to be minus 3. But I have only 1 Cl. 1 Cl can give us only a minus 1 charge, isn't it? So, I should write here Cl3 so that charge within the complex and outside the complex, okay, remain the same, but the sign is different. Plus 3 within the complex, therefore, minus 3 should be outside, or minus 3 should be due to the coordination. Minus 3 should be due to the counter ion. Okay, so next example now. Hexa-aqua iron 2 sulfate. Hexa-aqua iron 2 sulfate. Aqua H2O. Hexa 6 times. Iron Fe. Charge on Fe 2 plus. Sulfate. What's the charge on sulfate? -2. So the charge within the complex is +2. Charge outside is -2. So it's balanced by itself. FeH2O 6 times SO4 is the name of this, the formula of this complex. Next one. Potassium trioxalato. Potassium trioxalato. Aluminate. Trioxalato aluminate 3. Potassium trioxalato aluminate 3. So K for potassium, aluminium Al, oxalato. Let me write OX, or it is C2O4. Okay, OX 3 times. Now this is +3. Oxalato, each oxalato is -2, and you have 3 of them. So totally -6. Charge within the complex is -6. So charge due to the counter ion should be +3. Charge due to the counter ion is +3. So how can I adjust for this +3, right? K3 here. K3 AlOX3. Okay, so this is potassium trioxalato aluminate. You can also write it as K3 Al oxalato, C2O4 3 times. Okay, OX or C2O4 3 times. All right, so this is how we write the formula of the complex when the name is given. Most of the questions which we discussed now are ISE board questions. So you need to practice all these terms, all these names well. Thank you, and stay tuned for more videos.